All right, thanks everyone for joining today's session. As you all perhaps have seen from my LinkedIn and my Telegram channel, that today we're going to be discussing VPC, and we want to get started as soon as possible. But first, let's whiteboard and see, what we're really looking at when we're talking about VPCs. Thank you all for joining today's session. As usual, without me creating these live sessions, I don't think I'll be randomly recording videos and putting on YouTube. Okay, so having you guys here is what makes me actually come here and do this, right, and post it on YouTube. Otherwise, if it was something I said I'm just gonna record videos, I just keep procrastinating. So I know I have to be here for you guys, right? Thanks for joining. For those that just joined, at least after I started recording, please turn off your audio and your video. Please turn off your audio and your video, and make sure you're logged into your AWS console. Okay, make sure you're logged into your AWS console. All right, guys, whiteboard. Now, as you know, these sessions are for you to remove that fear of, what do I do on the job when I get a job, for AWS. If this is your first time joining these sessions, make sure you watch the previous sessions. They're on YouTube. I share the links at the end of this session. So yeah, watch those videos, be able to do those, and it will give you more confidence as you start to get interviews for AWS, cloud solutions jobs, right? Cloud architect, cloud admin, and all of that good stuff. Watch those videos to get the hands-on skills, to host websites on AWS, host your applications on AWS, and all that great stuff. All right, now guys, remember we've been launching EC2 instances all of this while, but we've been using default VPC, guys. We've been using the default VPC, right? And when we say VPC, think about it as a networking construct, right? Every customer in AWS have their own VPC, okay? And this VPC is where you can put in your virtual machines, right? Your servers, right? This VPC is where you put in your virtual machines, and this VPC is kind of like, think of it as the infrastructure that gives these machines, these servers that we'll be launching, it gives them the numbers they need for you and I to talk to them from outside, all right? It gives them either a private number or a public number, right? And in this case, we say private IP and public IP. But to keep things, more simple for everyone, so we can carry everyone along, for those that are already technical.
Are you sharing right now?
Oh, that's right. I'm not sure. Thanks. Thank you. I wasn't looking at my chat. Share. Which screen am I sharing? This one. Share. Oh man, you all missed that, but you see it in the video anyways. Let me close that. Okay, so I haven't really. So yeah, I was just saying, default VPC is what we've been using so far, and then here I drew like a box. So you have this. Machines right here, right? You guys remember all the machines we've been launching recently and putting our website code on there. And then this VPC gives these machines the IPs they need, right? It gives it either a public IP or a private IP. Private IP, think of it as a private telephone number. Only customers in this VPC can talk to you, can call you on that private number, right? For a public number, right? Everyone from the internet can talk to you if you have a public number to that machine, right? That's why you would see when we launched those machines previously, when we launched them, we had a public IP and we also had a private IP. So the public IP is what makes it possible for people from outside to be able to reach us, okay? Okay? Now, guys, let me do this. Now, every time before we launch an instance, here's what's happening. We choose a region, right? Guys, this will really, really help you in some of those interviews, at least if they give you these types of questions, right? How you're going to host an application with a database and things like that. So we choose a region usually. This is what we've been doing, right? We choose the Northern Virginia region, right? And within the region, remember, regions have different, let me say, cities in them. Right? Think about availability zones as different cities within a region that allows you to build, systems that are redundant, right? So that when one city crashes, the other city is still alive to host your application. And when I'm saying city here, please think availability zone, okay? Each region in AWS can have 2, 4, 6, right, availability zones, right? So in this case, Northern Virginia has 6, right? It has 6. So let's say there's one availability zone here in this region. Let's say we're just gonna use 2, right? In most cases, remember, as I said before, as a best practice, at least use 2 availability zones, right? When you are using in your production environment. In dev and test, yes, 1 availability zone, you don't mind if it crashes because it's dev and test, right? But if it's production, right, you always want to leverage at least 2, so that when this availability zone, this city, for example, in this region where these data centers are, if it crashes, if this goes down, your production, your website that is bringing you money is still going to be up because it's using this one on the right here. If this left one goes down, this is still available. So in reality, production systems, at least leverage 2 availability zones. So let's say this is AZ1A, right? And this is AZ1B, right? Guys, now in these availability zones, let's say we want to have subnets, right? Let me make that bigger, right? We want to have subnets, right? Subnets, right? And then here's another subnet, but I'll show you what I'm doing in a second. Here's another subnet. Okay? And all of this is within your what? Your VPC. Your VPC. Here's a VPC right here. VPC. Right? Now, when we've been launching instances so far, guys, we've been using the default VPC that was provided for us, right? But now today we want to go a little different, right? We want to do something different. We want to create our own VPC, and in our own VPC, we want to have public subnet. And again, guys, I want to please forgive me if today's sessions goes more than 1 hour, right? This is gonna be good stuff you're gonna like. If you cannot wait till the end, don't worry. You can, end and go do whatever, thing you need to do. And then you can watch the recording later, okay? So here, and then in another AZ, we have also public subnet, right? But in our case now, for what we want to do today, we want private subnets, right? We want private subnets. And we want another private subnet also in another place for, redundancy. Right? We want another private subnet here. Okay, so great job, right? Now, this is what we're doing so far. Now, to launch instances, the VPC we've been using so far in this class was the default, and that only had public subnets, right? That only had public subnets in all of the availability zones. Now, in our case today, as you can see now, we've added a private subnet. Why are we doing this? Because what we want to do now is, when we launch an instance here, when we launch an instance today, right? When we launch our instance today, we're going to put our web servers, let me put WS here, our web servers in our public subnet. Okay, and let's say we do it in 2 availability zones, just the same thing we're reflecting here. Okay, we want to put our web server in our public subnet. Okay, now for our private subnet, for what we did last class, we're gonna have to choose our what? Our private subnet for this. Okay, because we don't want to put it in our what? In our public subnet. We want to choose our private subnet to put our RDS. Remember, we're using a managed database service, right? We're not actually creating an EC2 and putting MySQL in there to act as our database. We're using a managed AWS database service, okay? So, but in that case, we can still choose the subnet we want AWS to create that database in for us for, okay? So in this case, we want a private subnet. We want that database to be in a private subnet, okay? So this is an RDS database. Let me just put database here. Of course, it will have its volumes, we're choosing 20 gig or 100 gig or 1000 gig. But again, that's a managed service by AWS. So if we're creating our own database instances, we want, it doesn't matter if it's a managed database service or if it's something we're doing on our own. For those that are not very technical yet, you're still learning all of these things. I know it might sound confusing that AWS can create a database and manage for you, and you can also create one and manage for yourself. Don't worry about all of that for now. Just know that with databases, no matter high level, you can create your own database on an EC2, or you can leave AWS to create it for you and help you with managing backups and giving you the option to just manually select how much backups you want to retain and all that. In other words, using a managed database service like RDS is a better solution. Okay, I wouldn't recommend you try to create your own database for your own applications. Use a managed database service that takes a lot of burden away from you, right, and your teams. And that's always what they're always trying to push for, right? Use a managed database service. Don't try to launch an EC2 instance and make it a database tier for your application. Okay, instead let that be a managed service for you. All right, enough of that. And also in this other part here as well, you have that RDS here as well. It's managed database service that's going to connect to that application is going to be using. Now guys, here's one thing I want you guys to note, right? When you put something in here, this when we create this, it's going to have route tables. Okay, there's going to be a public route table. Let me just put public RT, and there's going to be a private RT. And you guys will see this when we create this, right? There's going to be a private route table, RT against 10. I'm using that to denote public route table and private route table. Now, guys, if this subnet right here is connected to a public route table, here's what I want you guys to think. And when I was learning these things, it didn't make a lot of sense to me until like I always tell you guys, when you repeat a lot, it starts to make sense at some point. Now, this is what I want you to think. If you're gonna launch instances in a public subnet, okay, let's say there's another instance here, you have like 5 instances in here in this public subnet. These instances will be able to talk to the internet if they're associated with a public route table, right? Now for public route table, guys, here's the key. It will have what we call an internet gateway, IGW, okay? So if you want a subnet, in this case a public subnet, and we call it a public subnet because we want to have that idea in our head that I'm calling this a public subnet because these machines are going to be able to talk to the internet back and forth. Okay, so just keep that in your mind, that public subnet is attached to a route table, and this is the key thing here that gives it away. It has an internet gateway. So these machines here will be able to browse websites, and all of that good stuff. Now here, for this private subnet right here, that we're going to attach to a private route table, it is not going to have an internet gateway attached to it. Please keep that in mind. Okay, and I want you guys to take a screenshot of this architecture, of this diagram that I'm putting here. This is gold. This is money. Okay, if you're able to show this in interviews, you know what you're doing. Okay, to some extent, but something that that will make you stand out. Now, keep that in mind, guys. Now, some of you might say, but sometimes these databases, they need to talk to the internet, right, to download updates. That's good. That's a one-way communication, right? In this is the reality. You do want these machines right here to be able to go to mysql.com or whatever site it is, if you're using MySQL, to download updates from MySQL, right? You want to get those security patches or some important patches or updates to the database. Or it needs to go to Microsoft if you're using Microsoft SQL. Or it needs to go to Oracle to download Oracle patches and security updates and all that. Okay, but that's good. That's one way. It's the one requesting, right? But here, the internet can talk to it. It can talk to the internet. Okay, so in this case, when we want this scenario whereby these databases should be able to go and pull updates, they're the one going to pull updates. Nobody is asking for a page, right? I want to go to www.this.com. Nobody's requesting a page from this database. This database is a one-way communication, right? I can only ask you for something, right? These machines right here, these databases right here, because they need to do those updates, you are going to put in your in a public subnet what we call a NAT gateway. Okay, there's going to be a NAT gateway that's going to be attached to a public subnet, right? It's going to be called a NAT gateway. Okay, now guys, that NAT gateway, if these machines need to go to the internet, they will go through the NAT gateway in a public subnet. Okay, don't let that confuse you. The NAT gateway is the tool you need to allow those database servers to go out and fetch updates. Okay, and the NAT gateway has to reside in a public subnet. Keep that in mind. It has to reside in a public subnet. Okay, and now in the route table here, you would have a NAT gateway. Right, instead of an internet gateway, it would be a NAT gateway that will be what? Allowing that we route that communication from this machine through the public subnet to where it needs to fetch that update from. Does that make some sense? Does that make some? Where's my chat? Let me open my chat. Where's my chat? What is the difference between NAT gateway and direct connect? Direct connect is private connectivity between your on-premises and your office. So this is still, everything is still within AWS. So let's say you have a branch office somewhere. You have a branch office here, right? And you don't want to use public internet. Think of direct connect as a private internet service. Okay, just that one word, private internet service, whereby it's only there's a cable between your office and your office location. There's a cable that's only for your office and what? Your AWS environment. Okay, I'm not gonna talk too much on that. I keep getting this concept wrong in plastic, but now I finally get it. I'm glad you do. So keep this in mind, guys. I don't want to talk too much about this. Think about this architecture. Rewind this video multiple times if you have to. Okay, just keep that in mind. The NAT gateway is gonna be, if you see a NAT gateway in your route table, just label that route table private route table. Okay, as long as it doesn't have an internet gateway. Okay, internet gateway, public route table. NAT gateway, private route table. These things should give you clues as what you should label as your public route table or as your private route table, and you're going to see that in the lab in a session in a few minutes. Okay, please keep this in mind. And NAT gateway, remember, it's using a public subnet. It's not using a private subnet. All right, and guys, a simple question: if you want these machines in this public subnet to have internet connectivity, what should you have in the route? What should you have in the route table? What should be in your route table to allow that communication? Internet gateway. If you want your private machines here, your database servers, right, to be able to go and download update from the internet, they don't have internet connectivity, right? It's just that ability to go out and fetch updates. What do you need in the route table for them? A NAT gateway. Very good. All right, now let's move on. Now let's go to our AWS console. Go to your AWS console now. Now I want you guys to go to VPC. Go to VPC. Let's go to VPC real quick. Okay, let's go to VPC. So I'm going to click on VPC here. All right, I'm going to click on VPC here. Now, some tutorials out there might be showing you a lot of complicated ways to do this. Okay, here we're going to use a wizard. Okay, we're going to use a wizard that's going to give us everything we need. Okay, if there's anything beyond this is rare that you're going to have to do it one by one, create route tables here, subnets here. Just use the templates that are available. Okay, keep things simple. Use the templates that will make sense to what you're looking to do. In this case, there's a template that AWS has. Instead of having to go and create everything one by one, you might get lost in the way. But here's a trick that I want you guys to start thinking about. Use the wizard, right? Why not? Use the wizard. Now let's see how to do that. So go ahead and click on VPC dashboard. You have to click on VPC dashboard. Okay. Go ahead and click on VPC dashboard. Okay. I'll take questions at the end. I really don't want to look at the chat now because it'll just, guys, focus on this now. This is very important. We'll ask questions later. All right. So VPC dashboard, click on VPC dashboard and you can see launch wizard here. I'm going to click on launch VPC wizard. I'm going to click on launch VPC wizard and then it gives me some options here. Now, guys, I want to choose this because here's what the requirement our boss has told us now, or our supervisor or the senior architect, right? They said, we want a VPC and we're giving you this task, create a VPC with public and private subnets, right? And they tell you, we want to be able to have at least 256 subnets, right? 256 subnets, right? Just choose this. Don't worry, choose this, right? VPC with public and private subnets, right? They're telling you now that in the long run, this VPC should be able to have a total of 256 subnets. But for now, we're only going to use two of them. Okay, for now, we're only going to use two of them. But build it in a way, when you start it now, build it in a way that we can add more subnets in the future if you want to. But for today, we're only going to use 2 out of those, 256 that we're able to do. Now, choose this. It says VPC and with public and private subnets. Okay, we're going to choose that, and we're going to click on select. Okay, it'll tell you here what it's going to create. A /16 with 2 subnets, right? With 2/24 subnets. So go ahead and click on this. Go ahead and select this. Okay. Now, guys, it automatically puts a /16 here for us. Right? It automatically creates a /15 here for us. Right? Now, guys, with this setup here, I want to bring your attention to some things. Don't worry if you don't know what number to put here. Do not worry. Go with the default, guys. In most cases, your network engineers will handle this numbering, this CIDR notation. We call them classless interdomain routing. Let me see in the chat. Any network gurus in here? Any network gurus in here? Anybody? There's usually 1 or 2. Nobody here is a network genius? Kind of. Okay, good. All right, so guys, your network engineers on your teams, you have CCNA. Okay, that's one right there, CCNA, right? So your network gurus will handle this for you. Now, with this default, now with this address, now, there is a website that you can go, guys. If you, let's say you're the one that puts this here, this /16, you say, okay, now AWS tells you, you look at the documentation. Are you following, guys? And that's why I said this might take a little over an hour today, but trust me, you're going to learn a lot of good stuff. Now, guys, if you go to this, let me post it in the chat. Let me put that in the chat real quick. And put that in the chat here. Okay. If you go to this address, I want you to call your attention to something. Look at this right here. It says you can only create between a /28 and a /16. But as we're using the default now, it automatically picked what? /16 for us. Okay, it automatically picked /16 for us. Right? Now, here we have /16 as the VPC CIDR, right? This VPC itself that we wrote here in the architecture, right? This VPC here, it needs its own IP CIDR address, and then these subnets right here also needs their own CIDR address, right? I'm just gonna put 24 here. Okay. Now, guys, based on this /16 or this /28, it will determine the number of subnets you can create in your VPC. Okay, if you change this to a /28, the lesser subnets you're able to create, right? Something like that. Now, here's what I want you to think of to keep things simple for us, guys. Those of us that are not network gurus or anything like that. Let's say you choose a number. You look at the documentation and it says, okay, you can only choose between /16 and /28, and you say to yourself, okay, we're also going with /16. But in our case, we want to have more than 2 subnets. As you can see here, it's only going to create 2 subnets for you. A /24. It's only creating 2 for now, right? And it's using /24. It's using /24. Okay, for the subnets. This is our public subnet, and this is our private subnet. Take note of this, guys. We're gonna have 2 subnets in this VPC. Okay, let's give the subnet and let's give the VPC a name. Let's call this test VPC. Okay, or your company will give it a name. Why is that in uppercase? Test VPC. Okay. Now, guys, /16 as the overall VPC address we're using. Okay, as the overall VPC CIDR block we're using. /16. Keep that in mind. /16, and this could be /28, /22 So something between this, the documentation says /28 to /16 is what you can use. So /16, guys, and it tells us here that you can have 65,531 IP addresses, right? If you go with this. Now, for us now, if we're gonna do this, and we said we want to have at least, let's just choose any number. We want to be able to create 16 subnets. We want to be able to create 38 subnets or 32 subnets, right? Or 24 subnets. There's actually a type of number that you can use for this. Now, let me go to what makes this very simple for us. Okay, and I was just using those numbers as an example. I know there's certain numbers, 2, 4, 6, there's a range that you can use. Okay, so let's say in our case, we're gonna take this number now that you've chosen. Take this number, guys. Here's what I want you guys to do. Okay, take this number that you've chosen as for your VPC CIDR block and come to this website right here. This is the best one I've seen so far. This is the best one that makes things so easy for me that I'm not a network engineer or a network expert, but I know some basic networking, right? Everyone needs to know some basic networking and the basic security and all that, right? To do well on this job. So with some of these basic things that I know, this website makes things very easy for me, right? Perhaps the network engineers can calculate this by hand, right? But everybody uses this. Even on the job, this just makes things very easier for you. Now, you're going to take that number and you're going to put it here, okay? You're going to put it here. Let me give you guys the link. And you guys are wondering where's the link. Here's the link right here. Here is the link. Let me give you guys the link. So you can go to that address as well. Now, we're taking this number, /16 is what we're using for our overall VPC. All right, we're going to plug it in here, which I've already done. Okay, I plug it in here. Now, I say to myself, my company says we should be able to have 256 subnets. Right, what do? Look here. It makes it very easy, guys. It says number of subnets you want. Look, you see, and that's why I said you don't just say 3 subnets or 5 subnets. There's a certain number you have to choose. Now look at that, guys. 256. And then it'll automatically give me what I need to use for the slashes, for the blocks, for my subnets. So that way, in this case, I have to do a /24. Do you see that, guys? I don't have to know which block I need to use here. Take note, I'm going to be using the word slash a lot, and you know what I mean. So sometimes you might be confused. So should I use a /17 / don't worry about that. Just put that number there, right? What you want to use. Let's say you want to use /22. Okay? Just come here, say, I'm just using an example. We're going to end up using /16. I'm just using, let's say here, just put /22. And this is, how many subnets do you want to be able to create? How many subnets do you want to be able to have? For a few, maybe you're just going to use 2 for now, right? You're going to launch in one public and one private. But let's say in the future, you want to be able to create more subnets. And before you start the whole creating VPC now, you want to make sure you're able to expand in the future. So let's say we can have 32, right? Now it'll show you what you need to have, what each subnet needs to have, what address each subnet needs to have. So each of these will be what? Your first subnet will be this /27. Your second will be this /27. Now let's go back to our 16 example. I'm going to go back here. I'm going to put this, guys, /16. Wow. Oh, this makes me, I like to see, because this is what I feel too when I understand these things. And I hope this makes it easier for you guys now, right? Wow, that has been a bottleneck for me so long. I hope this makes sense now for many of you too that have been learning this in other places and it just doesn't make sense. So think about this. You have the links to this. Look at this again. Let's erase this. 16 is what we want for our VPC. Copy that. Copy that. Go to this website, put it in there. Okay, our VPC is going to be /16. And at the end of the day, we want to be able to create, let's see. It gives us options here. 512 subnets. There you go. Now, in this case, 256 is what we've been told. We want to be able to have at least 256 subnets. There you go. So now our first subnet is going to be this. And look, that's what AWS has here for you. Right? So now the second subnet is going to be this. Look at this. Look at this, guys. Now let's see. Does this match what that website is telling us? Look. 10010. Does it match? Yes, it does. 10010. Now, because this is going to create only 2 subnets for you, and let's say we want to be able to create 4 subnets, right? Want to be able to create 4 subnets. Now, what will our third? You don't just put in any numbers, guys. It has to be these numbers. But since you're not the network expert, but now you know what to do. What would the third subnet be, guys? Who can tell me? Just looking at this. If you want to add another subnet, it doesn't matter, a private subnet or a public subnet. Remember, adding an IGW or NGW is what makes it private or public. Now tell me, guys, looking at this, I want you guys to tell me what is going to be my third subnet. If I create this now, right? I cannot add another one here. It says I can add more after I create the VPC. Let's say now I created the VPC and I want 2 more subnets. What is my next 2 subnets gonna be? In the chat, There you go. Excellent. The third one will be this. That's it. The third one will be this. And the fourth one will be what? The fourth one will be what? What would the fourth one be? What would the fourth one have to be, guys? Quickly. There you go. And then AWS will start assigning numbers from this range to the machines that you create. Right? To the machines that you create. Now, if they ask you, for each subnet, how many machines can you launch in a subnet? Who can tell me? From what you have here, something is given away. Something gives it away here. How many can you? Thank you. 256. There you go. So for each subnet, I can launch 256 virtual machines. But wait, there's a catch. AWS says we're going to borrow some of those. Some of those numbers we are going to borrow. Okay, you cannot use them. And if you look at the documentation, it says here, look, hey, we're gonna steal some addresses for you. And that's why I know. When you look here, it says 251 and not 256. Does it make sense now, guys? Does that make sense? Yes. Can I get some yeses on the chat? Oh, good. All right, guys, let's move on. Let's create this. Now, guys, I'm gonna warn you, okay? If you're gonna continue with this, because we do need a NAT gateway, guys, just for the sake of the lab, today's lab, there's gonna be a charge of about 45 cents, okay? If you don't worry, if you cannot afford that, just watch the video. But if you can, for every hour you use a NAT gateway, it'll charge you 45 cents, okay? But that's something, I can do today. I hope many of you can do as well. There's no free tier. A lot of people are asking AWS, please provide free tier for NAT gateways. They don't. They just don't at this point. So 45 cents for an hour. So an hour is enough. 45 cents. Okay, that's fine by us. Now I'm gonna open a new tab here. Why? Because as we're creating this for the NAT gateway, you need an elastic IP. You need an IP that will not change. So that's why it's gonna ask you that you need an elastic IP. Okay, I have one from before, but don't worry. Let's do it again. Okay, open a new tab. Okay, and then go to VPC again. Make sure you leave this running. Okay, just leave this for now. Now we understand this makes sense to us now. Okay, now go here, click on VPC. I want you to click on elastic IPs. Okay, go ahead and click on elastic IPs on the left. Now go ahead and click on let me release this one that I had before. Okay, so now we have the same thing like as you and I. Okay, all right, now click on allocate. Okay, click on allocate. Leave everything as default. Yes, Northern Virginia region is what we want. Okay, yes. Click on allocate. Okay, I'm gonna click on allocate. Okay, we're gonna Amazon, yes, provide the IPs. Some companies they have their own private range, so AWS can allow them use their private IP ranges. But in this case, not many people do that. Only if you really advanced and you know what you're doing, then you're gonna say, okay, we have our own IPs that we want to use. All right, now guys, we have an IP here. We have an elastic IP here. Okay, we have an elastic IP here. Now click on this. Now that it's been created for you, go to the AWS Management Console and then put it in there. If you click on the box, it'll automatically refresh and pick up that elastic IP. An elastic IP is an IP that you can attach to something that will not change, even if you restart that something. And that something can be a virtual machine, right? An EC2 instance. Okay, so let's go ahead and select that. Okay, let's go ahead and select that. All right, now leave everything else as default. Tenancy is default. We're now using dedicated instances or dedicated hosts. Just leave it as default. Okay, so now that that is done, let's go ahead now and click on create VPC. Now, remember so far, although we can create 256 subnets, we're only creating 2 now. Now let's change the names a little bit. So VPC name, test VPC, public subnet. Yes, I think the names are fine. Public subnet, private subnet. Yes, okay, let's leave it at that way. Okay, now let's go ahead and click on create VPC. And this might take a few minutes. How about we go back to the other tab and start to launch an instance. Click on AWS on the other tab. Please leave your VPC tab creating, okay? NAT instance is you are doing creating NAT yourself, okay? You're doing that NATing yourself, right? I don't know how to explain NAT in this case, but in other words, if you want NATing, right? In the case whereby your database servers are going to go out, but the outside cannot reach out to them directly, you're going to need a NAT, right? What's the full meaning of NAT? Network address translation? Yeah, right? So in this case, AWS has a managed service. Okay, think about AWS creating the NAT instance for you. Otherwise, NAT instance, you are going to have to launch an EC2 instance and use that as a NAT. You are going to have to create a virtual machine, an EC2 instance, and be able to set up NATing in that instance. But in this case, we don't want to do that, right? If there's a managed service, just use it. And AWS always recommends that, right? Just to reduce the administrative overhead, right? Because that NAT instance that you create on the VPC in an EC2 instance, it can break due to some other, but if we're managing it, rest assured that it'll always be up and all that good stuff, okay? A lot of people I do see some posts like that online. They said, the NAT gateway is expensive, so some people prefer to do it themselves. If you can do it yourself, go ahead. And of course, that should be easy to do. A lot of YouTube videos will show you how to create a NAT instance. So that way you're only paying for a T2 micro instance, and you don't have to pay for a NAT gateway. Okay. A lot of people do say that using NAT gateway is expensive, but of course, think about the benefits though. Right, you don't have to manage that EC2 instance that is doing that NATing for you. Okay, and think about how you have to make that NAT instance highly available, right, by having a multiple availability zone. But NAT gateway, all of that, redundancy and all that already built in. So think about you're paying for that extra, admin work that they do for you with the NAT gateway. So yes, it is pretty expensive, but we're only going to need for 1 hour today. Okay, all right, guys. I hope that makes sense. Now let's go to VPC here. Let's go to our VPC. Your VPCs. Now this is default. Okay, you guys had the default from before. If you like, this is what I like to do, just so that from now on everything makes sense. I'm gonna change this name here. Now this already has our name. This VPC here already has the name we gave it when we created it. Okay, but this one is the one that comes with your account. So what I usually like to do is I like to change the name here and just say default. I like to change the name here and just say default. Enter. Save. Okay, so that way I know that this is the default that was created by AWS. Okay, default VPC, but just keep that in mind. Now, guys, this is the new VPC we created. This is the new VPC we created. Okay, now it comes with subnets. If you go ahead on the left, click on subnet. As you can see here, it already has a name for us. So public subnet and a private subnet. Very good. Now, what else, guys? Route tables. Route tables. Route tables. Route tables. It already comes with a route table as well. Okay, now look here, guys, and I want you guys to help me here, and this will tell me if you guys understand all of that whiteboarding and all that thing that we did. Now you're looking at these two route tables and you're thinking, so which one should I call my private route table and which one should I call my public route table? I need you guys to help me out here. You guys should help me out here. Okay, no, default VPC, you don't get charged. Okay, only when you create resources, guys. And please leave the question. I can't help it. When I see these questions, I just answer them. Please don't ask questions until the end, guys. Please, okay, please, let's wait till the end. Okay, so guys, let's follow this for now. Now I'm looking at this route table and I'm asking myself, so which one should I call my private route table and which one should I call my public route table? Who can help me out quickly in the chat? Who can help me out? How can I tell? How can I tell which one I should quickly label my public route table? My public route table or my private route table? Let's go. Second is public. Are you sure second is public? Why? Public has yes. No. That's just saying it. No, that's not what it is. That's not what we're looking for. Let me say that's not what we're looking for. There's something that I mentioned when I was doing the whiteboarding session, right? There was something I was mentioning there. Yes, maybe you can use that as an idea, right? But there's some, before I click on it, I want to see if you guys know what I'm talking about. Right? Okay, let me click on the second one that you guys are talking about. Let me click on the second one. Okay. So you're saying we should call this our public route table, right? Public. Let's do it like this. Public route table. Okay. Let's say I agree and I do that. And then let's call this our private route table. Let's call this our private route table. We could be wrong, but let's see. Our private route table. Okay, you guys said to do this. Okay, you said the second, but what's gonna make you be sure that that's right? What's gonna make you be sure? Let me see quickly, and I'll just go ahead and show you the answer. route to IGW is public route table. The one with an explicit subnet association is the public. Yes, means it's enabled and it's the public that had internet gateway. Okay, I like all of these things that you guys are throwing out there, and it does make sense, right? But here's what I want you to do. Just click on it. Click on it. Look at the route. Look at the route. If you are calling this public route table, look at the route. What should the route table have, guys? What should the route table have? Before you call it your public route table, what should your route have attached to it? What should your public should have IGW. Very good. Now let's click on it. No. So you see, we were wrong. This is not our public route table then, guys. Okay, although it says main, yes, good guess, guys, but no. Now we have to change this. Why is that? Who can tell me why? Because we see now what? A NAT, right? A NAT gateway is what's attached to this. So whatever subnet uses this is not going to have internet connectivity. But the database servers can go out and pull updates. So this is a private route table, guys. So we have to change this now. Private. We have to call it private route table. Okay, now this makes sense. Now let's look at the other one. Now you guys help me out here. Okay, it's already there. Now as you can see, this needs to be called our what now? Public. Why is that? Because it has an IGW, internet gateway. So let's change that now. It shouldn't be private. It should be what? Public route table. But it's a good learning experience. Now you see how you can make sure, right? From now on. Now you see how you can make sure. Let me go ahead and change that back. Public. Enter. Okay, good. Now we're clear. Okay. Public route table. Now this was the route table from our default VPC. And if you look at this one that was created by our default VPC is going to have internet gateway, because that's just what that comes with. One public subnets only, and all those public subnets will need to use a route table that has an internet gateway. So don't worry about that. Let's focus on our own VPC that we created. Okay. Does that make sense? Can I get the number 5? If that makes sense now. And if you guys can from now on confirm what to name your route tables. Very good. Very good. All right, guys, let's test. We're almost done. Let's test. Let's see if we can launch instances in these machines and you can communicate with those instances by going to the websites that are on those machines. Okay? But there's one thing, guys, and a lot of people miss this. When you create your VPC, you should otherwise, when you start launching instances in your public subnet and you're like, where's the public IP for this machine? And it's not there, you haven't enabled something. You have not enabled something on that public subnet. Now let's go look at the subnet. Go ahead and click on subnets. Now look at your public subnet, guys. Look at your public subnet. You need to do something for it to have public IPs assigned to it. Okay? Now if I scroll, what do you see here? Auto assign IP is no. Okay, auto assign IP is no. So that needs to change. Now, if you change this to yes, any machine that you launch in this public subnet is going to be given a public IP, which is what we want. So we need to do that. Okay, so go ahead and click here, actions. Make sure you select the public subnet for our own for our own test VPC. Okay, go ahead, check that. Now click on actions. Click on modify auto assign IP settings. Okay, and then click on enable. All right, click on enable and click on save. Okay, click on enable and click on save. Okay, enable and save. All right, now that's pretty much done, guys. That's pretty much done. Now, because we don't have much time here today, we wouldn't use the application that has the database attached. We're just gonna use one random one. Okay, in future sessions, we're gonna do one with it. We're gonna put our database in. If we do that now, it'll take more time than we want. We're already at 11:48. But let's just test the VPC that we've created today by using one of those examples, one of those applications that doesn't really need an actual database. like the one we did last class. So we're just gonna pick one that just has that we don't have to connect it to a database. Okay, if you've been following it so far, you know what I mean by that. And I want you guys to go to your S3 bucket. Remember the buckets I told you to keep, right? And you're gonna see that in my own console. Everybody should have this too. Okay, so we're gonna use this one instead of this one, site with DB. Okay, I know you guys might want us to test and see if we put this database, if we create a database and we put it in our private subnet, is it really gonna still work and all that? Don't worry, maybe perhaps we can do that next week. Okay, but for now, let's just move forward and test and just use our public subnet to just launch an instance for today. Okay, so that we can have our Q&A session. All right, and you can try that, on your own. Create a database and choose your private subnet and test it if it works. But take note of security groups, though. Take note of security groups. Not to confuse us too much. Has everyone done that? Because that is important before we launch our instance. Have you done that auto-assigned IP check? Let me get a 9. Have you done that before we move on? Have you done that? Okay, very good. We're moving on, guys. We're moving on. All right, only Hiba. Anybody else? Only Hiba? Okay, Obafemi, good. All right. Obafemi, are you in Nigeria? Are you connecting from Nigeria or you're in the US? Wow. All the way from Nigeria, watching this. Nice, thanks. I saw your LinkedIn and I saw Nigeria, like, Obafemi has been joining from Nigeria all of this while. That's some commitment right there. Okay, guys, what am I doing? VPC, instance. Let's go and launch an instance. So now we're done with VPC. We've created our test VPC. We've created 2 subnets, and we know we can have more subnets in the future. Okay. So let's go ahead and again, we're going to use this one. So copy that. Let's go and grab the code. Okay. I've already given the links to these 2 links, to these pages. Okay. So I'm going to close them. I'm going to use them for something else. Let's go ahead to our drive. And let's get the code. Remember the code that helps us to load our website easily? Our bash script. Okay, let's copy the code. Open a notepad. For me, if you're using Mac, just use a text editor. And so this website, this S3 bucket doesn't exist anymore. Well, like I said from a previous class, we're only going to start using this one right now. Okay. So think of this, when we use this, it's a website that doesn't need a database. Okay, so let's copy this. But this one, remember, this is our PHP MySQL application. And you guys saw how we did that last week, right? We created a database because this application needs a database. You saw how we did that last week. Here is just a simple, beautiful website. It doesn't need a database. So we're going to use that. Okay, so let's go ahead to that editor right now. Let's just make sure we have that ready. Let me put that in there. Okay, so this is the website we want to load on the machine when it's done. All right, so let me copy that. Now let's go ahead and launch an instance. Let's go ahead to AWS now. Let's go to AWS. Let's go to EC2. So you want to test. This was a task that was given to you on the job. You've created now a separate VPC for your company. Sometimes there are some projects that you're going to be using your own custom VPC for, and there are other projects within your company that you're going to be using the default VPC. Okay, so now let's go to running instances. Sorry guys, as I mentioned, I know we're gonna go a little over an hour today, but I hope the benefit outweighs you guys know what I mean. But again, sorry for always keeping you guys more than an hour. I wish I could keep this within an hour, but let's see here. What am I looking for? Can I have you want the user data? You have the link to the drive. If I put it in the chat, it doesn't come out well. That's why I want you to use the drive. Do you have the link to the drive? Don't worry, I can give you the link to the drive. Okay, just give me 1 second. Lab files. Here's the lab files. Okay. And don't worry, if you're not able to catch up, don't worry, you can watch the video later on. All right, moving on, guys. Go ahead and click on launch instances. Okay, let's go ahead and click on launch instances. Error loading. This happens sometimes. Just refresh. Okay, we're refreshing. All right, guys, look at this. Amazon Linux. Okay, that's what we want for our web server. Go ahead and select that. Okay, T2 Micro. Yep, for free tier, that's what we want. Go ahead and click on configure instance details. Okay, now how many machines do we want? We want 1 web server for now. Okay, we're creating 1 web server. Now, guys, are we using the default VPC? Yes or no? Absolutely not. We want to use our own VPC now. Remember, so far we've always been using the default. Now let's test what we've done with our own hands, right? So now we're gonna, if you select it now, you can choose your own VPC. All right, and that's our test VPC. Okay, subnet. Okay, which subnet do we want? We only have 2 subnets in that VPC, as you can see, and that's why we have how many what? 2. Okay, we have 2 subnets, right? Public subnet and a private subnet. All right, now let's go ahead, and don't worry that it put this in the same AZ here. If we create our own, we're gonna choose like different AZ. If we add 2 more subnets, you know, I would recommend choose 1A and 1B. Okay, I wouldn't use the same. Okay, I wouldn't use the same AZ to create my public and private subnet, right? So I'll just, you know, pick 1A or 1B. But for now, it's okay. We'll take it. 1C. Just go ahead and choose this. 1C. Okay, and public. Make sure you choose public. And before we move on, guys, if I choose private, what will happen at the end of the day? If I choose private for this machine that I'm creating, what will happen? In the chat, real quick, someone tell me, why are we choosing public here? Just give me a brief summary. Why are we choosing public here? So that the internet can talk to us. Okay, it's a web server. Okay, very good, very good. All right, so go ahead and choose public. Okay, use subnet settings. And what's our subnet settings? Auto assign IP. Okay, auto assign IP. If you forgot to check that, I believe doing this would work, but I'm not sure, guys. The best way I've been doing it so far is make sure that I check that auto assign IP that we did for the public subnet. But don't worry, just choose here, leave here, use subnet settings, which is what we said. Auto assign IP, and that's gonna happen by leaving that as that. All right, IAM rule, as usual, I said always use your S3 and SSM rule. What else? Shutdown behavior, terminate. When we shut down, terminate it. We don't need the server. Okay, this is all demo. What else, guys? Our user data. So that, you know, this has been making things so easier for us now that we don't have to wait for the machine to launch, and then we're gonna update the instance, and then we're gonna install Apache. This script does all that for us. Oops, wrong script. This script will do that for us, and it will pick up that code and put it in the HTML folder that it needs to be in for it to work. Okay, so there it is. There it is. We put that. Okay, I make sure I'm referencing my S3 bucket. I make sure that I'm referencing my S3 bucket. That is done. Very good. I'm gonna go ahead now and click on add storage. Okay, let me just make sure I'm not forgetting anything. Okay, go ahead and add storage. Okay, go ahead and click on add tags. 8 gig is good. Let's call this name web server. Okay, let's just give it a web server name. All right, go ahead and click on configure security group. Okay, as you can see, our security groups from before are not here. Why? Who can tell me why? Real quick. Who can tell me why our security groups from before are not here? Come on, you guys know this. You guys know this. Because, come on, we don't have more time left. Why? Why is our security groups from... We're using a new VPC. Simple as that. We're using a new VPC. Very good. All right, now let's go ahead and create SSH. Yes, we want to allow SSH. We want to be able to SSH into it, but also don't forget HTTP, so the world can reach us on that door, on that port number. Remember, I use door just to keep things easy for those that are not very tech savvy. And HTTPS. Okay, so this will be opened, and this also will be opened. Okay, but to who? We want it to be open to the world. Yes, for now, open to the world, right? HTTP. But to make this a little more secure, I would say do it to your own IP. Okay? Do it to your own IP. Only for a load balancer should you make this open to the world if you're using a load balancer. But for now, we know we're not using a load balancer. So for us to test from anywhere in the world, would use this. But to keep this a little bit more secure for us, we can say, okay, allow it to our own IP. Okay? Allow it to our own IP, allow it to our own IP, and then also this allow it to. Don't worry, this public IP is not mine. Okay, it's provided to me by VPN service. Okay, I know you guys might think my public IP is okay. Yeah, you never want to show people your public IP, but I'm using a VPN. It's gonna change. All right, guys. and let's call this private to me. That's what I do. When I create a security group like this, I call it private to me. Okay? I call it private to me. If you're not going to use a load balancer, guys, if people are going to connect directly to your web server, guys, please, this HTTP and HTTPS has to be everywhere. Okay? But this is just a test to keep things a little bit more secure because we're just testing our own environment. We want to act like we're coming from the outside, but hey, only allow our own IP. Okay? I hope that makes sense. So I'm just calling this private to me. Okay? Private to me. Okay? You can call it, public security group if you make this 0.0.0. I hope that makes sense. Private to me. Go ahead and click on review and launch. Okay? Go ahead and click on review and launch. So the security group I'm giving it is private to me. The name is private to me. So I know that everything that's allowed in there is private to is going to be allowed only to my own IP address. Okay? So go ahead and click on launch instance. Okay? Now I have a key pair, and I hope you guys also have a key pair that you've been using from the previous classes. Go ahead and choose that key pair. Choose I acknowledge and click on launch instance. Okay? Now it's launching the instance for me. Let me go ahead and click the instance. Okay? Now it's showing me that it's pending. Guys, we're almost done. We're almost done. Okay, we just want to test. Okay, it's pending. Who is with me so far? Now we're just waiting, guys. We're just waiting to test. That's all. We are just waiting to test. Type the number 5 if you're with me so far. Type number 5. Let's go. Very good. All right, let's just wait. Remember, I always like to have that 2 status checks. 2 out of 2. AWS is checking, is everything good with this machine? Is everything good on our end? Is everything working, as you set it up as well? So let's wait for 2 out of 2 checks. Usually if you test before the 2 out of 2 checks, it works sometimes, but sometimes it doesn't work. But at the end of the day, just make sure you get a 2 out of 2 check. And what address do we need to go to? We need to go to this address right here. Okay. And remember, as an example, for your end users, for your customers, they need to go to your website. This is what you want to give them. Right, the DNS. And remember, you can customize this. Like I've said, you use a service in AWS called Route 53. Some of you might be familiar with GoDaddy. Okay, those services can allow you customize this to mukhtarkabir.com. Okay, yourname.com. Okay, but for now, we're gonna use what we get from AWS. Copy this as something we're gonna give our customers. Here, our website is up and running. Go to our website. Okay. Still initializing. Let me test and see if it'll work without the 2 checks for now. Okay, it works. All right, like I said. All right. The number 9 in the chat real quick. The number 9, if you got this up and running in your own VPC, you created your own VPC, put in a public subnet. Good. There's a 9. Another 9. Very good. We have come to the end of today's session, guys. And don't worry, we'll test our private subnet as well and put a database in our private subnet and see if our web server can still talk to it. Don't worry, we don't have time to do all that today. Perhaps that will be something for next class as well. Moving on, guys. If you're using my bash script on the job, just take note that different applications. Okay, if you find this script very helpful, you've been using it, think of this as these are for codes that are written in PHP, right? You have a PHP and MySQL backend, okay? And don't worry, yes, MariaDB will work if you're using MySQL for your database. If your developers are writing applications in Node.js or in Django, don't worry if you don't know those names, okay? Those are just programming frameworks and languages that are used to write these applications and make them available to users. Okay, so developers use different languages, right? PHP, JavaScript, Node, React, Angular, different languages and frameworks are used. So depending on what is used, this will not work. For example, if the website is written in if it's a Node.js application, okay? But don't worry, guys, as you're following me every week, we're going to take example by example. Let's say your developers are coming with you and, hey, this application is written in Node.js, so know how to put it on a web server and make it work for our customers to see. Don't worry, we'll get there. But for now, if it's an HTML, if it's written in, if it's simple HTML web page, okay, has some what do you call it? JS script in there, as you've seen with this example, for example, it can work. Okay, this will work. If it's HTML, if it needs an Apache server, this will work. Okay, but there's some that need some other things to run. For example, Node. You need something like npm, right? You need something like nodemon, right? Don't worry about these names. You will get to know those when we get there. But for most websites that you see today that are not very complicated, they're not using modern, frameworks and things like that, this would always work, right? For example, for PHP applications, go ahead and use this. It will work. Again, please, just make sure you're looking at to use best practices. Don't say I gave you this and I told you to use it in your production servers. Okay, test, follow best practices, but this makes it easy for you to get going. Let's open the floor now. Let's open the floor now to Q&A. Let's open the floor now to Q&A. So please remember to terminate this server. Terminate the server instance. Terminate. Yes, terminate. Leave your default VPC. Okay. Go ahead and remove your NAT gateway. Go ahead, guys, and remove your NAT gateway. Remember, it's 45 cents per hour. If you leave it till next week, you're gonna see a big bill. We don't want that. Go ahead and remove your NAT gateway. Let me go ahead and let's go to VPC. You have to do this. I hope you haven't dropped off yet. If you have dropped off, you probably will not hear that. But go ahead now to VPC. Let's go ahead to VPC. Exactly, we don't need the NAT gateway now. Exactly, go ahead and remove it. The wizard wanted us to create it, so let's go ahead and remove the NAT gateway. Click on NAT gateway. Go ahead and click on actions. You only have one, so that one is automatically checked for you. Go ahead and click on actions in your NAT gateway. Delete NAT gateway, guys. This is important. Okay, if you see a bill next week, it's not me. All right, but I did tell you about the 45 cents, for an hour charge. Okay, go ahead and delete NAT gateway. Okay. It says type delete here. Type delete. I'm going to go ahead and delete. Okay. All right. Deleting. All right. Go ahead and remove your elastic IP. Thank you for that as well. Let's remove our elastic IP as well for now. Okay. If we need it next week, we're going to take it. We're going to create a new one. Go ahead and release our elastic IP. Go ahead and release disassociate elastic IP. Okay. Disassociate. Okay, you don't have permissions to I think there's a reason why it's doing that. It's because our NAT gateway is still deleting. It's because our NAT gateway but this is important, guys. Please wait. Let's do this. Let's release this, because if you have an elastic IP that you're not using it with a resource, you're gonna get charged. Okay, from what I understand, elastic IPs are free as long as you attach them to a resource. Remember, it was previously attached to a NAT gateway. So now that we're not attaching it to anything, then it can cost us money. Otherwise, it's usually free, from what I understand. So let me go back and make sure that our NAT is deleting. It says it's deleting. It says it is deleted. Okay, now let's go back to our elastic IP. Let's go back to our elastic IP. Elastic IP, actions, disassociate, does not exist. Okay, can we delete it now? I think it's gonna go away by itself, right? I'm getting something mixed up here. Okay, yeah, there you go. Release, guys. Sorry, release elastic IP. Release. After it's disassociated from the NAT gateway, go ahead and release. Okay, AWS can have it back. We don't need it for now. Go ahead and release. Okay, and then that's it. It's gone. All right, release. All right, guys. Floor is open. On me, the first, we're only going to take 2 questions. Good thing we didn't really go, it's just 12:08. So we didn't go very far from our 1 hour scheduled. So I'm only going to take 2 questions and that's it. 2 questions, guys. Please help me out here. Don't let no third person ask her a question. Please, 2 questions only. First person, go ahead.
Hello, Mokhtar.
Hi.
Thanks for doing this. So I just want to, just a clarification. I actually drew like a similar architect last week, and I posted it on LinkedIn, and somebody mentioned that it's not a best practice to put the web server in the public subnet.
Yeah,
that I should put it in private subnet. So I was just wondering, like, can you speak to that?
Very good. Thanks for bringing that up. And I don't know if you guys remember from one of my previous sessions, I mentioned some people will tell you, as you know, just as a more security, for more security consciousness, right? Don't put it in a public subnet. Put your web servers as well in a private subnet. Now, different companies have different reasons why they will do that, right? Different companies have different reasons why they will do that. What I want you guys to focus on is, even if you do this, even if you put your web servers in your public subnet, make sure that it's only allowing communication from IPs that you trust, right? Or security groups that you trust, right? In other words, if we're going to use a load balancer with this, if we're going to add a load balancer, guys, if we're going to add a load balancer, then we want to make sure that the security group is only allowing communication from who? From 0.0.0? No. From what? From our load balancer security group. Okay, so that way, even if you do this, it's still secure, right? But these machines here are going to have internet connectivity. Okay, now if you remove it from here and you put it in your private, it's not going to have what? Internet connectivity. Means even if you have SSH open to the world, people are not going to be able to try to ping you because you're not public, right? Your IP is private to everything that is within your VPC. Which brings me to another point. Guys, even though this machines here, it doesn't matter. You put a web server here, you put a database server here in your private subnet, all other machines can talk to it. All other machines in your VPC, not from the internet. All other machines inside of your VPC can talk to it. Okay? Because every machine here gets a private number. A private number that they can use to call each other. If that makes sense. Okay? Every machine in here gets a private number that, hey, we're family. All right? We're in the same VPC. We can talk to each other. Okay? But depending on if you want that communication to go outside of your VPC, then that's where you start saying, okay, I want to put it in my public subnet or my private subnet. Okay? But at the end of the day, if they're in the same VPC, machine A in private subnet can talk to machine B in public subnet. Okay? As long as the internet is involved, route tables. Okay? Your route tables, and you start saying, okay, internet gateway for everything in my public subnet. For my private subnet, NAT gateway to allow that one-way communication only. So, in other words, now think about this now. If I take my web server and I say, okay, I really don't want it to have internet connectivity for some reason, right? I'm not going to ever remote into it to try to, download something, or even if I want to, it's going to be using my NAT gateway, which is fine. Or there's no reason for the outside world to talk to me directly. So let me just put in my private subnet. Do that, okay? In the real sense, you're more secure that way. Since the internet cannot initiate communication with you, there's no reason to. But look at it. Why does this still work? Because you have a load balancer. Let me not draw another load balancer. Because you have a load balancer that the world can talk to get to the web server. The web server security group is allowing the load balancer security to talk to you. But guess what? The load balancer can accept communications from the world. So it's still going to work. Okay? That's why that will work even if you put it in your private subnet. Okay? Because the load balancer can talk to it at the end of the day. But here, if you're not using a load balancer, then you want to do this. If you're not using a load balancer and the world needs to talk to your web server directly, then you put it in your public subnet. Okay? So in reality, I will tell you, if you build this in a production environment, really, really, really look at putting your web servers also in a private subnet. Okay? If you're not doing that, at least make sure the security groups is tightened. Okay? It's tightened to what? Allowing connection to your load balancer if you're using a load balancer, or to your own IP if you're not using a load balancer. Okay? Does that make sense, Olumuyiwa?
Yeah, perfectly well. Thank you.
You're welcome.
That was the suggestion that was added to the diagram. So I added load balancer and I put the load balancer in the public, and I moved the web server to the private. So
very good.
It's
Did you test
the security group that allows communication from the load balancer with the web server in private group? So you answered it very well.
Very
I just
good.
want the clarification for people so that they can also
Right. Cool.
Thank you so much for
thank you.
That
was a beautiful question. Thank you. Very helpful. All right, guys, one more, and that's it.